Alright, so I'm attempting this problem called longest consecutive sequence. Given an unsorted array of integers, return the length of the longest consecutive elements sequence. You must set an algorithm that runs in O of n time. So here, uh, the longest consecutive elements sequence is 1, 2, 3, 4. Okay, so we're not looking for like a sub array, we're looking for a sequence or a set rather, which forms this longest consecutive sequence. So we pick 1, we pick 2, we pick 3, and we pick 4, and we make this. Okay. Another example. Here the answer is 9 because you have 0, 1 till 8. So 0 to 8, all the elements are present, which is why uh, the output is 9. Now, some constraints. The array's length is maximum 10 to the power 5, and the values could be between minus 10 to the power 9 to plus 10 to the power 9. Okay. Interesting. Let's think. What can we do? So let's think about this first array again. Let's copy this array here. One of the things is I was thinking is could we sort, but then sort is n log n, right? So, but if it's sorted, we could maybe do some passes of the array and figure out. So we can't sort, so we forget about that. Now the length of the array can be 10 to the power 5. You could convert this array to a heap or like a priority queue. Converting an array to a heap is O of n, right? And then what do you do after that though? Removing n elements from the heap would be each element you remove would be log n. So if you process the heap, it will become n log n. So can't use heap. Just for us the understanding sake, once we had sorted, what was the algorithm? What would the algorithm look like? So let's say if it was indeed sorted, so 1, 2, 3, 4, 100, 200. Then I would walk through the array till it's consecutive. So from 1 to 2 to 3 to 4, it was consecutive. It break at 4. So when you know because it was consecutive and it is breaking, you obviously just need to start on the next guy and 100, 200. Yeah. So if it's sorted, it's very easy to do a single pass. But it is not sorted. Hmm. What sort of a processing that we can do? Maybe just save the ranges. What does that mean? What does that mean is you walk through the array and let's try to create some sort of a hash set or hash map, right? So 100, nothing, no information. You save in some map or a set. Then you get 4. Yeah, literally no information again. Hmm. As you let's say you generate the entire hash set. I mean it is taking a lot of space, like O of n space, but I guess we take up that much space. So let's say we generate a hash map which says, hey, this element is present at this index. And what do we do then? Um, then we walk through each of the keys of the hash map and check if a +1 or -1 of that is present. Okay, so for 100, 99 or 101 is not present. Okay, for 4, 5 is not present, but 3 is present. So we go to 3, we make the count as 2, and we know that uh, we came from 4, so we have to go down. We have to go only backwards. Yeah, and then another thing that we need to ensure is we need a visited. We have to mark visited as well. That hey, I visited this guy, and so 4, 3, 2, 1, right? Exactly. So okay, so I'm thinking something like from 100 I don't find anything. Then I go to 4. I say okay, so 4 is present. Is 5 present? No. Is 3 present? Yes. So 4, 3 is a combination. And I keep going off because I'm going in a decreasing order. So, and there's no point in going in increasing order. So I see after 3 is 2 present. Yes. Is 1 present? Yes. Is 0 present? No. So this is the maximum length that I could get. But now the thing is I do not want to process these elements again. So the next key, let's say, is 200, and 200, okay, no plus minus. And I go to 1, I should know that I have already processed 1. So once I've processed a key, I also mark maybe another set then, which says, hey, I processed this. Okay. So I don't really need, yeah, so I maybe just 2 sets. And other is, all right, so we generate the present has set. So for okay, this is so far linear. Now walking through the keys is again going to be linear. So for each, yeah, if num sort length is 0, so we'll return max here anyways. Now for each element in the set, we check if a -1 or +1 is present. So you know, obviously current is 1, and then check increasing, you said present and num, and also pass visited. Also mark this visited as true. So visited dot add num, and you also check in decreasing. And then you do max equals to math.max current. This was quite clear. Now how do we generate this check increasing and check decreasing? Okay, let's do this. So check increasing is, okay, you're passing and this. So we do int count equals to 0 and while num so firstly we have to not I mean really could you have visited it, but okay, I mean just for our sake it's anyways overcome. We'll do if visitor does not contain this. First present dot contains uh, none plus count. Nope, none plus. Interesting. Yeah, let's do int I equals to 1, num plus I. Or rather, just do count plus 1, yeah? Num plus count plus 1. So it will become num plus 1. The present contains this and visited does not contain this. Then we do our count plus plus. We mark it visited as well. Okay, so this is good. And what else now? Yeah, I think that's it. And then once you break out of this condition, you return false. So you return count. And let's do for same for check decreasing. Minus count minus 1. So starting with num minus 1, then count will be, let's say, become 1. Let's say count becomes 2. If count becomes 2, that means, okay, so let's say we are at 4 and we are checking 4 minus 1, 3. Count becomes 1. So then we'll do 4 minus 2, 2. And yeah, so this is all good. So basically, even though these are, these both of these have a while loop, but overall, because we are using visited, we will ensure that each key is only visited once, and so this is why uh, this generation was linear, and this loop is linear as well. So overall time visit is linear. Space complexity is also linear. Let's run code and see if it works. Okay, you need two elements, current and max. Wrong answer. Okay. So what did we get wrong answer? So let's do this. We should, yeah, okay. So one thing I need to do is if visited contains num, just continue. Don't wanna, yeah, this was a bit I missed. And now what I want to do is here I want to check. This is the guy I'm checking, and after I check this, what is the value that I got? Right, let's quickly see for whom we got what, which value. Okay, so this is not helping that great. Let's do, and yeah, I think this is fine. Let's run again. Okay. So 1, 200, 4, 200. That's one thing is clear that we are only. So where is 3? Because 3 has been visited. Fine. We are outputting 2. So we did for 1. which is good. So we first key that we checked was 1. We only got 2. Okay, so 1 would have been added here. Check current plus equals to check increasing. Check decreasing should have returned 0 right away because uh, it would not contain 0, but it should contain 2. I did do a count plus plus and visited dot add, which is fine. Now when I do okay, so this is the problem. I have to change this visited before incrementing the count. Yeah, okay. Now run again. Right, so for 1 we get 4, for 100 we get 1, for 200 we get 1. Yeah, the other 1, 2, 3, 4 we didn't have to really walk through because we already gotten this one. Yeah, let's run for all test cases. Okay, it works. Let's remove the debug prints and submit. Right, wrong answer. Let's check this out as well. What happened here? Okay, so for 0 we got 2 as the answer. That means the check either the check increasing or check decreasing worked, but not the other way around. So I feel because check increasing was working, I feel like the check decreasing might have some problem. Let's quickly check. Check decreasing. Yep, it has this problem of copy pasting. Has to be this, has to be this. Okay, run code again and removing the prints again and submit. And this time it moves. So yeah, that's it. It should be linear. Time complexity as well as space complexity. Both time and space complexity should be over fine.